In this tutorial, we'll build a responsive search filter using React and Tailwind CSS. We'll fetch user data from an API, allow users to filter the results in real time, and implement a clean and modern UI. By the end of this tutorial, you'll have a fully functional search filter component that's both interactive and stylish. Let's get started.
Let's dive right into setting up our React app using Vite. First, open your terminal and navigate to the folder where you want to create your project. Run the following command. Once you hit enter, it will ask you to select a framework. Use the arrow keys, select React, and press enter. Next, it'll ask you to select a variant, choose JavaScript. Once that's done, move into the project folder with CD and put your project name here. Now, install the dependencies by running npm install. After the installation is complete, start the development server with npm run dev. And there you go, your React app is up and running using Vite. You should see the default Vite plus React welcome page. Now we're ready to build our search filter functionality. Alright, now that we've got our React app up and running, let's quickly install Tailwind CSS to style our search filter. I'll be going through this step quickly, but as always, follow the official Tailwind CSS documentation if you need more details. Now that we have Tailwind CSS installed, let's clean up the default boilerplate code so we can start fresh. And there we go, we now have a fresh setup with all the boilerplate cleared out. Let's start building the search filter component next. Alright, now let's set up the structure for our project. We'll create a components folder to keep our reusable components organized, and inside it, we'll create the search filter.jsx file. First, inside the src folder, create a new folder called components. This will hold all the components we use in our app. Next, inside the components folder, create a new file called searchfilter.jsx. This file will contain the code for our search filter component. Now let's quickly set up the basic structure for the search filter component. Add this code. This is just a placeholder for now. We'll build out the actual search functionality in the next step. Finally, let's import the search filter component into our app.jsx file. Update it like this. And there we go. We've set up our project structure and added the search filter component. Next, let's build out the actual functionality for our search filter. Alright, to enhance the design and make the search bar more intuitive, let's add an icon to it using the React Icons library. Let's get started. Now let's import icons for our search bar. We'll use the IO search icon for the search functionality and the IO iOS close circle icon to clear the input field. Both icons are from the React Icons package. Now let's style our search bar with Tailwind and add icons. For the search bar, we use the IO search icon on the left and the IO iOS close circle icon on the right, which clears the input when clicked. Now let's style our search input using Tailwind CSS to make it look clean and responsive. Now that our search input UI is ready, let's make it appear at the center of the screen. To achieve this, we'll start by styling our app.jsx file. First, open app.jsx and add the H screen and W full classes to the parent container. Update your code like this. Next, let's go back to searchFilter.jsx and center the search input. To do this, we'll use Tailwind's Flex utilities on the parent container. Update the parent div like this. Now your search input is perfectly centered on the screen. Now let's make the close icon clickable by adding the cursor pointer class. In searchFilter.jsx, locate the close icon, IOIOS close circle, and update its class name to include cursor pointer. Now save the file and the close icon will be interactive and visually indicate that it's clickable. Next, let's fetch some user data from the random user API. Inside the search filter component, we'll create a state variable called data to hold the results from the API. We'll then use the fetch data function and call it inside a useEffect hook to fetch 20 random users when the component mounts. Here's the code. First, let's create a state variable to store the fetched user data. This will hold the results we get from the API. In the search filter component, add the following state hook. Next, we'll create the fetch data function that will fetch data from the random user API. The function will call the API and update our data state with the fetched results. Here's the code. Finally, let's use the useEffect hook to call the fetch data function when the component mounts. This ensures that the data is fetched as soon as the search filter component is loaded. After the useEffect hook, add a console log data inside the component to log the fetched data to the console. This will help us verify if the data is coming through correctly. Once this is done, you should be able to see the fetched data in your browser's console. The data should contain an array of 20 random users, and we can move forward with using this data for filtering and rendering in the UI. Now that we've successfully fetched the user data, let's implement the list UI and display the users from our data state. First, let's add a container below the search input to display the filtered user list. Inside the search filter component, just below the input field, we'll map over the data array and display each user's name along with their avatar. Now, let's render the user's first name and last name from the data array using the map method. So now here you can see the list of 20 users rendered below the search bar. Now let's render the user's picture along with their first and last name. We'll wrap them inside a div for better structure and styling. Now our user's picture, along with their name, is rendered successfully. Let's design the list by adding some Tailwind CSS for a clean and modern look. Now you can see that our search input with the user list is looking good, clean, and resembles a real-world application. Let's move on to the next step. Let's create the main functionality, which is the search filter. First, we'll create a state variable called search query to store the user's input from the search bar. This will allow us to filter the user list dynamically based on what is typed into the search field. Next, let's make our search bar functional by adding the value and onChange attributes to the input field. The value attribute will be set to the search query state, ensuring the input field always displays the current state. The onChange attribute will update the search query state every time the user types something, allowing us to capture the input dynamically. Now, let's create the filter data function to filter the list of users based on the search query. Inside this function, we'll filter the data array by checking if the user's first and last name combined includes the search query. We'll convert both the user's name and the search query to lowercase to make the search case insensitive. Now that we have the filter data function in place, we need to replace the data with filter data in our JSX rendering. This is because filter data contains the filtered list based on the search query, while data holds all the users without any filtering applied. Now on the UI, you can see it's working. Whenever you type in the search input, the data is dynamically filtered based on the user's input. The list updates in real time to show only those users whose names match the search query. This creates an interactive and responsive search experience for the user. Now, if we search for something that isn't in the data, the UI currently shows an empty list. To improve this, we can add a condition that checks if the length of filter data is equal to 0. If it's empty, meaning no users match the search query, we'll display a message saying "No data available." Now you can see on the UI that when you search for something not in the data, it shows no data available instead of an empty list. Now let's create the clear search function, which will clear the search input when the user clicks on the close button. We can achieve this by setting the search query state to an empty string. Next, we'll attach this function to the close icon's onClick event. So when the user clicks on the close button, it will trigger the clear search function and reset the search input. Now, let's make sure that the list of filtered users and the close button only appear when there's text in the search field. To do this, we can check if the search query is greater than 0. With these changes, the list of filtered users and the close button will only be visible when there's input in the search field. If the search field is empty, both the list and the close button will be hidden, making the UI cleaner and more intuitive.
That's it for today. We've successfully built a search filter component in React with Tailwind CSS. We set up a search input that filters data dynamically, added a clear search function, and improved the UI with conditional rendering to show or hide the list and the close button based on user input. I hope this tutorial was helpful. If you enjoyed the video, don't forget to like, subscribe, and leave a comment with any questions or feedback. Thanks for watching, and see you in the next video.